Doxycycline is a semi-synthetic tetracycline compound. Classically, this drug is used in podiatry and wound care for its properties of antibiosis and antisepsis. There have, however, been some investigations of doxycycline and other chemically modified tetracycline species, which demonstrate its potential as an inflammatory modulator. These qualities may prove useful within a wound environment. This is particularly so as an inhibitor of nitric oxide production, matrix metalloprotease activity, and tissue necrosis factor alpha converting enzyme. MMP activity has been identified as a key player in the environment of chronic wounds as well. Although MMPs are part of the normal breakdown and remodeling of tissues within the human body, non-healing ulcers are particularly less governed by regulatory mechanisms and therefore see an overabundance of MMP activity and consequently lead to the persistence of inflammation and degradation of the epithelial matrix in situ. The chemical structure of doxycycline has been investigated and demonstrates satisfactory results as an inhibitor of such zinc-catalased protease activity. By inhibiting the activity of various MMP species in a wound bed, the breakdown of wound matrix may be prevented. Similar to MMP inhibition, TACE, otherwise known as ADAM17, is a member of the same metalloprotease superfamily, and thus inhibition works by zinc binding as well. As a surface-bound enzymatic protein, TACE degrades pre-TNF-alpha, thereby converting it to a biologically active form. Doxycycline has demonstrated convincing results in lowering the conversion of pre-TNF-alpha to its active form. Because TNF-alpha has long been known as a powerful member of the entourage of inflammatory cytokines of chronic wounds, the ability to suppress its expression could potentially be to the patient's advantage. Next, the presence of nitric oxide within a wound environment is made possible by its production via the iNOS enzyme. The mRNA molecule which codes for iNOS is expressed during times of cytokine and inflammatory stimulation. This mRNA molecule has a relatively short half-life, which is presumed to be for regulatory purposes, and is stabilized by the presence of p38 MAPK binding to one of its several AUUA motifs. When doxycycline prevents p38 MAPK from stabilizing iNOS mRNA via competitive binding to metallic ions, subsequent degradation of the iNOS mRNA molecule takes place, and therefore acts to decrease the concentration of nitric oxide within the wound environment. Although further investigation is needed to ascertain the true beneficial value of doxycycline as a wound chemotherapeutic agent, laboratory data is highly suggestive of this possibility.